In today's video, we will be going over some electricity questions from Prepware's General Electricity Study Guide. Most of these questions involve math and Ohm's law, and these are the ones I'm going to be focusing on. Ohm's law has two common formulas. They are E equals I R and P equals I E. You could also use a circle type system, which makes it much easier to solve equations. So, E, I, R, P, I, E. Let's go over what these letters stand for. E, I, R, P. The E stands for voltage, symbol V. The I stands for current, amps. The R stands for resistance, or ohms, symbol. The P stands for power, or watts. Let's start going over some questions. Okay, let's begin with our first question. This question is asking which requires the most electrical power during operation. Note 1 horsepower equals 746 watts. You can just cross that off because none of these answers requires you to calculate horsepower based on watts or whatever. So answer A. Okay, so for all of these answers, it's pretty much saying which requires the most electrical power or wattage, and we're gonna figure out how many watts each answer gives us. Again, we're gonna be required to use Ohm's law. Okay, 12 volt motor requiring 8 amps. So we have volts, we have amps. What we don't have is P. So P equals IE. P equals IE, which is volts times amps, 12 times 8, or you can do the circle way. P 12, 8, so 12 times 8, 96, 6 equals 96 watts. Pretty simple. Okay, answer B, 4 30-watt lamps in a 12-volt parallel circuit. Note, it says parallel, and note, it says 4. So it already gives us the watts that each lamp is using, and since it's in a parallel circuit, we just add up 30 4 times, or you just multiply 30 times 4, which would give you 120 watts. Okay. Answer C. 2 lights requiring 3 amps each in a 24-volt parallel system. So note, it says 2 lights, and it's also in a parallel system. Okay, so 2 lights requiring 3 amps in 24-volt circuit. We have amps, we have volts, we don't have power. So power, amps, volts, multiply them. 3 times 24, 72 watts. Well, that's only for one light. 72 watts for one light. Remember I said there's 2 lights, so all you do is multiply by 2, and it's in a parallel circuit. If it was in a series circuit, it would be a different answer. 72 watts times 2 would be 144 watts equals 1. So the answer out of all these three would be answer C, because that is using the most amount of power. And there's the explanation. Okay, when the landing gear is down, the green light will not come on if an open occurs in wire 7, 6, or 17. So, for a light to turn on, it needs ground and it needs power. There's the bus furnishing power. There's two circuit breakers. And those are all the wires going to green light switch, red light switch, horn, whatever. The 7 and 17 wires are only for the push to test circuit. If you don't know what a push to test circuit is, or whenever you've seen this like little green little triangle, red has it too. It's when you push the lamp in the aircraft, and if it lights up, the lamp works, and if it doesn't light up, and it doesn't work. That's what the test circuit is there for. So you could automatically cross these answers out, leaving us with wire 6 goes from the bus through the circuit breaker, 6, 5, 4, 3 goes to the green light and goes to ground, which makes 6 our answer. There is the explanation. Okay, which requires the most electrical power? Note 1 horsepower equals 746 watts. We will be needing this. Okay, let's find which requires the most power or watts. A 1/5 horsepower 24 volt motor, which is 75% efficient. Okay, we have 1 horsepower equals 746 watts. 1/5 times 746, which is the same as 746 divided by 5, is 149.2 watts. Then it says it's 75% efficient. So we do a simple ratio formula. 75 over 100, 149.2 over x. Let's solve for x. So 149.2 times 100 divided by 75, 198.9. X equals 198.9 watts. Okay. 4 30-watt lamps arranged in a 12-volt parallel circuit. So it already gives us the watts. All you gotta do is calculate the amount for 4 lamps. 30 times 4 gives you 120 watts. A 24-volt anti-collision light circuit consists of 2 light assemblies which require 3 amps each during operation. So don't forget 2 light assemblies. If you're wondering what an anti-collision light is, that's just there to trip you up. All you really need to know is that it's a light and it's drawing current, creating power. So Ohm's law, I, which is the current, 3 amps. E is the voltage, 24, 3 times 24, 72. Then you have to multiply that by 2 because we have 2 lights, times 2 equals 144. So we have 198 watts, 120 watts, and 144 watts. Our answer is A. When the landing gears are up and the throttles are retracted, the warning horn will not sound if an open occurs in wire 5, 6, or 7. Okay, there's the warning horn. Warning horn needs ground, needs power. Okay, let's trace it. There's the power coming from the bus. Goes down. Goes to wire 10. Goes through the warning horn. Now has to find ground. Question says the throttles are retracted. So it has a path to go through. And the landing gear is up. So there's the left gear switch, there's the right gear switch. We have an indicator saying they're down right now. So let's put them in the up position. So you cross that out, put it here. Cross that out, put it here. Now, let's keep going, keep tracing our wire. Okay. Since the gear switch is up instead of down, there's no ground here to find. So we could eliminate wire 5. Okay, let's go the other path. Through 6, up, and we find ground. So if you go back to what it's asking, the warning horn will not sound if there's an open in wire 6, since it's configured as the landing gears up and the throttles retracted. We don't really deal with anything up here because it's only asking for 6, 5, and 7, and this is a test circuit, so we're not going to deal with that. What is the operating resistance of a 30-watt light bulb designed for a 28-volt system? So we're going to need the resistance, ohms, and we have two variables. We have watts and volts. We can use these formulas. So if you use E equals IR, we have E, we have volts, but we don't have current and we don't have resistance. Well, we're trying to find resistance. So we could use P equals IE. We have power, we have 30 watts. And we have E, 28. We could find current. So 30 divided by 28, 1.071. So since we have I and we have E, we could solve for R. So let's do that. E, I, R. E is 28. I we found 1.071. Resistance we could solve by dividing 28 by 1.071. And it gives us 26. Resistance equals 26 ohms. B is our answer. There is your explanation. If resistor R5 is disconnected at the junction of R4 and R3 as shown, what will the ohm meter read? Okay, so it's pretty much asking what the total resistance of the circuit is with the breakage at this point. So we could redraw the circuit. Okay, since this breaks, these two become in series, and this section, and this section become parallel. So to add resistance in a series circuit, which we have 6 ohms and 6 ohms, we will get a total of 12 ohms, which now these become a singular entity, you call it, since we just added both these values. They give us 6 ohms for this resistor and 12 ohms for this resistor. Now the formula to get total resistance of a parallel circuit is resistance total equals 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3, etc., etc., etc. We only have 3 values, so we're only going to go up to 3. So we could do 1 over 12 ohms plus 1 over 6 ohms plus 1 over 12 ohms. Just plug that into a calculator, so it will be 1 divided by 12 equals plus divided by 6 equals plus 1 divided by 12 equals. And don't forget, we have to divide this number by 1. So simply hit this button. We get 3 ohms. That's our answer. There's the explanation. Okay, how much power must a 24-volt generator furnish to a system which contains the following loads? So again, we're going to have to find the total amount of watts we will need for all of these systems, all of these elements. Okay, it gives us one motor, 75% efficient, 1/5 horsepower, and it gives us the watts for 1 horsepower. So 1/5 horsepower would be 746 divided by 5 gives us 149.2 watts. But if it's 75% efficient, we would do 75 over 100 and 149.2. Let's find x. Cross multiply. 149 times 100 divided by 75 equals 198.9 watts. Okay, that's done. 3 position lights, 20 watts each. So if it's 3 of them, 3 times 20 equals 60 watts. Okay, 1 heating element, 5 amps. That's an Ohm's law. So PIE, power. That's what we gotta find. We have the volts and we have the amps, 24 times 5 times 5, that's power. 4 times 5 equals 120 watts of power. So we have that. One light, 3 amps. So again, Ohm's law, 24 times 3 equals times 3, 72 watts. Equals 72 watts. Okay, let's add this, and this. 198.9 plus 60 plus 120 plus 72 equals 450.9, which is about 450 watts, and that is our answer.
Under which conditions will the ground be provided for the warning horn through both gear switches when the throttles are closed? So this is asking for both gear switches and the throttles being closed. So let's do that on the diagram. So here's the bus, power coming in, 28 volts, warning horn, throttle switches are closed. Then these two gear switches have to be configured in a way for the warning horn to sound. So in this configuration, the warning horn cannot get ground because the left gear switch is down. So if you put the gear switch in the up position and trace the current going through the warning horn, through the throttle switches, through wire 12, through the up gear switch, left gear switch, through wire 5, and to ground through the down gear switch. So in this configuration, the left gear switch is up and the right gear switch is down, which would constitute a warning horn that is sounding. Left gear switch is up and right gear is down. C would be our answer. A circuit has an applied voltage of 30 volts and a load consisting of a 10 ohm resistor in series with a 20 ohm resistor. What is the voltage drop across the 10 ohm resistor? Well, let's draw a wiring diagram. So we have the battery, EIR. We already know it's 30 volts, so E would be 30 volts. Then we have one resistor of 10 ohms in series with another resistor, 20 ohms. So EIR, EIR. And keep in mind, this is a series circuit. So we already know two values, 10 ohms and 20 ohms for each of these resistors. So we could plug in 10 ohms, 20 ohms. If we add 10 and 20 together, we could get a total resistance of the circuit, making it 30 ohms. So we could solve for the current. EIR. So 30 divided by 30 would give us a current of 1 amp and that would continue on through the circuit. 1 amp, 1 amp. So it's asking what is the voltage drop across the 10 ohm resistor. So since this is the 10 ohm resistor right here, we have to find the voltage drop only on this resistor. So we could solve for E. So I times R, 1 times 10 would be 10 volts. And that is our answer, A. How much power is being furnished to the circuit? Okay, what do we have here? We have 23 amps, 5 ohms. This is looking like another Ohm's law problem. So E, I, R. So we have amps, we have resistance, 23 times 5. Gives us 115 volts. But it's asking for power, it's asking for watts. So we're going to have to use the other formula, PIE. Power equals current times voltage. So we got the volts, 115 volts multiplied by the current, 23 amps, give us watts. (2,645 watts). And C is our answer. What will be the effect if the PCO relay fails to operate when the left-hand tank is selected? So PCO relay, left-hand tank is selected. This is your selector switch. This is the left-hand tank detent. So this is our PCO relay. Let's trace out the current, where it's going. So it comes from the bus. If the left-hand tank is selected, it would go down here. It would operate the LTS relay, closing this contacts. So then the current would go through here. Go up to the PCR relay. So it asks us if this relay fails, what would happen? So like it is right now, there's no power going beyond this point, So if it did go through this point, what would occur? The fuel pressure crossfeed valve opened light in the cockpit would illuminate. So if the PCO relay does not operate, this light will not illuminate. So if you look at our answers, the fuel pressure crossfeed valve open light will not illuminate. And that's our answer. And there's the explanation. A 1 horsepower 24 volt DC electric motor that is 80% efficient requires 932.5 watts. How much power will a 1 horsepower 12 volt DC electric motor that is 75% efficient require? Note 1 horsepower equals 746 watts. So the first part of this question you could completely ignore because it's irrelevant. This is all we need. So how much power will a 1 horsepower motor need that is 75% efficient. So we could solve this with a simple ratio. So we already know that we're going to need watts as our end answer. So, and we already have the 1 horsepower. So 746 watts over 1 because it's 1 horsepower, and 75 over 100. We cross multiply. 746 times 100 divided by 75 give us 994.66 watts. So 994.66 watts. Answer C. The TCO relay will operate if 24 volts DC is applied to the bus and the fuel tank selector is in the right hand position, crossfeed position, or left hand tank position. Okay, so let's figure out what this relay needs to operate. It would need power coming in through this wire, going up, and coming in through this terminal, which is linked to the FCF relay. So we could trace that up, and that would be the crossfeed position. So let's trace it out again. So we're coming through here. The fuel selector would be in the crossfeed position. It would go down, operate this relay, which would operate this terminal switch. Close this here. Now since this is closed, it has power coming in from up here, going down, going through the closed switch here, going back up, operating the TCO relay. So, and the answer would be crossfeed position. The control valve switch must be placed in the neutral position when the landing gears are down to, okay, so the warning horn, the control valve, and the 2 gear switches. So it's asking why should this be placed in the neutral position when the landing gears are down. So this down indicates that both right gear and left gear are fully locked down, and the control valve is used to allow the warning horn to operate if there's a discrepancy. So if one gear is up and the other one is down, the warning horn would sound. So we could trace that out by, there's power coming from the bus going through the horn. If the throttles are closed, would allow the current to go through here, go through wire 5, 10. So if the control valve is not in the neutral, find the total resistance of the circuit. Okay, to find the total resistance, we're going to have to combine some of these values. So we can start by combining these 2 parallels and make them in series with R2. So we know to combine 2 parallel resistances, you could use the formula 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. So we have 12 and 6. So our formula would be 1 over 12 plus 1 over 6. then we can redraw the whole schematic and continue on. So 1 over 12 plus 1 over 6 gives you 4 ohms if you combine these two resistances. Let's redraw it. We have our 24-volt battery. We have this, and this is the one we just combined, which gave us 4 ohms. We have 12 ohms, another 4 ohms, and 18 ohms. So what we could do now is we can combine 4 ohms and 12 ohms simply by adding, because they're in series. So if we add them, 12 plus 4 gives us 16. We can redraw the circuit. There's our battery. We still have 18 ohms over here. We still have 4 ohms over here. And we just got 16 ohms from combining these two, which is this. So now, again, we have two parallels, 4 ohms and 16 ohms. We could do the same formula. Let's do it. So we had 4 and 16. 1 over 4 plus 1 over 16. And 1 over that is 3.2 ohms. So 3.2 ohms. Let's redraw it. So we're gonna have our battery. Our 18 ohms. And our 3.2 ohms. 24 volt. This really doesn't matter, but I'm just adding it just for the sake of drawing it. So this is now a series circuit. Find the total resistance of the circuit. So the total resistance would be 18 plus 3.2. 0.2 gives us our total resistance, 21.2 ohms. And our answer is C. Determine the total current flow in the circuit. Okay, let's see what they give us. They give us 12 volts, a resistor of 30 ohms, a resistor of 60 ohms, and a resistor of 15 ohms. So what we could do is E, I, R, P. So we have E, we have 12 volts. We don't have current, which they are asking for, and we don't have resistance. So we're gonna need resistance to solve for current. So how do we get total resistance? We're gonna need the formula 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. So we have R1, R2, R3. We can simply plug these values into the calculator, which we could do right now. 1 over 30 plus 1 over 60 plus 1 over 15 equals, and 1 over that. We get a total resistance of 8.57 ohms. So now that we have total voltage and total resistance, we could solve for I. So E I R. So we have voltage, we have resistance. E divided by R will give you I. So 12 divided by 8.57 gives you 1.4 amps. And we have 1.4 amps. B is our answer. The number 7 wire is used to, we have the bus, we have 5 amp circuit breaker, we have the number 7 wire, and it goes to the red light and the green light. Well, if you notice that little triangle sticking up where the wire ends, this means that this circuit is used as a push to test circuit, which means when the pilot pushes on the lamp, it will indicate if the light is burnt out or if it's operating. If it's operating, the push to test circuit would work and the red light would light up, or the green light will light up, whichever he presses. So our answer is A. Close the push to test circuit. A 24-volt source is required to furnish 48 watts to a parallel circuit consisting of 2 resistors of equal value. What is the value of each resistor? Well, to start this problem off, I like to draw a diagram of what it's asking. So a 24-volt source, so E, I, R, P, this is for the whole circuit, total EIRP. So it's saying we have 24 volts, E, we could plug it in, 24 volts, and 48 watts, which is power. So we're going to have to solve for current and resistance. And then we're going to have to find, well, let me try this out first. So we have 1 resistor, 2 resistors of unknown value. That's what we have to find out. What is the value of each resistor? That's what we don't know. But we could solve the total resistance and the total current based on these 2 values. So we have pi and EIR. So we have E and we have P. We have E and we have P. So P divided by E gives you I. 48 divided by 24 is 2 amps. So now we have E and I give us R. So E divided by I, E, 24 divided by 2 is 12, which gives us total resistance. Now, if you got to this point, you're probably thinking the answer is B. Well, that's not true, because this is the total resistance of the whole circuit. This isn't a single resistance of, so let's call this R1 and R2. These are equal, by the way. It tells us they're of equal value. So if you got 12 ohms at this point, the answer 12 ohms is wrong, because that's not the total that's the total resistance. That's not the resistance of any of these 2 resistors. So we could automatically cross that out, and we're left with 6 ohms and 24 ohms. So if we have, say, 6 ohms and 6 ohms, we could do the formula 1 over R1 plus 1 over R2 And if this formula, if we plug in 6 into this formula and we get 12 ohms, then that's our answer. Let's try it out. It's 1 over 6 plus 1 over 6 and 1 over that. That gives us a total resistance of 3 ohms. And we need 12 ohms, so that's not our answer. So let's try 24 ohms. So 1 over 24 plus 1 over 24, and then 1 over that, gives us 12 ohms total resistance. And that matches our total resistance, which we got from just drawing it out and using these two formulas. So that's our answer. These two values are 24 ohms and 24 ohms. How many amps will a 28 volt generator be required to supply to a circuit containing 5 lamps in parallel, 3 of which have a resistance of 6 ohms, 2 of which have a resistance of 5 ohms each? Okay, the simplest way I like to do this is just drawing it out. So we have our power source. Always draw your power source first. So we have total E, total I, total R, and total P. I always like to do this first. So, and don't forget our formulas: E, I, R, Ohm's law, by the way, P, I, E. Okay. So we have three resistors of 6 ohms. So 1, 2, 3, and then 2 resistors of 5 ohms. 1, 2. So we already have 28 volts. So let's draw in our resistors. So 6 ohms, 6 ohms, 6 ohms, 5 ohms, 5 ohms. All right. What we could do now is pretty much find the total resistance by using the formula 1 over R1 plus 1 over R2 plus 1 over R3. We have 5, so it's going to be plus 1 over R4 plus 1 over R5. So let's just do that. Okay, that gives us a total resistance of 1.111111. 1.111. Okay, now that we have that, we could solve for I. We could solve for current. So to solve for current, we have E and we have R. So E divided by R, 28 divided by 1.11111 ohms, volts, gives us amps. 28 divided by 1.1111 gives us 25.2. So going back to our question, how many amps will a 28 volt generator blah blah blah? We already solved. We got the total resistance. They already gave us the voltage we could solve, and we got 25.2 amps, which this is our answer, C. And this is our explanation. When electrical power is applied to the bus, which relays are energized? So, when electrical power is applied to the bus, 24 volt bus, only 2 relays are energized, which are PCC and TCC. So current flows from the bus through the left-hand 5 amp circuit breaker and through contacts 5, 7, 9 into the fuel pressure crossfeed valve through contacts 11, which goes back up into the PCC relay coil, which energizes it. So we could actually draw that out, which way the current flows. So through the bus, this gets energized. Okay, let's go to the right hand side. So it comes from the bus, 5 amp circuit breaker, it goes down through contacts 18, through contacts 20, goes back up, and to the TCC relay coil, and then energizes it. So our answer would be PCC and TCC. Find the total current flowing in the wire between points C and D. So our current is going from the battery through this resistor and through these two resistors. So we could actually combine R2 and R3 and get a value of how much total resistance is in between these 2 points, because the only current going through these 2 points are from these 2 resistors. So 1 over 10 plus 1 over 40 gives us our total resistance of these two, well, combined resistance. So 1 over 10 plus 1 over 40, then 1 over that gives us 8 ohms. Gives us 8 ohms. So we could actually redraw this circuit. So 24 volts. So that's C and D. So we got 8 ohms here, and we already had 8 ohms here. We can calculate the amps just by using Ohm's law. So we already have 24 volts. So E, I, R, P. We don't really need P. It's all right. So we have E, 24. We have ohms, 8 ohms. To find the current, we just use Ohm's law. So E, I, R. E divided by R, 24 divided by 8 gives us 3 amps. And that would be the current going through points C, D. So 3 amps is our answer. A 48 volt source is required to furnish 192 watts to a parallel circuit consisting of 3 resistors of equal value. What is the value of each resistor? Okay, we could calculate the total amounts of total voltage, total current, total resistance, and total power. So we already have 2 of these values. We have voltage, 48 volts, and we have power, 192 watts. So using Ohm's law, P divided by E gives you current. So 192 divided by 48 gives us 4 amps of current. 4 amps. Now that we have E and we have I, we can calculate R. E divided by I, 48 divided by 4, 12 ohms. So if you got 12 ohms and you click 12 ohms and you thought that was the answer, you're wrong. You're wrong because that's not the value of each resistor. That's the total resistance of the whole circuit. So you can do some trial and error here since you already have the values of, they already give you the equal values of all three resistors. You can simply just do, let's pick 36 ohms. So 1 over 36 plus 1 over 36 plus 1 over 36 equals, and then 1 over that. That gives us a total resistance of 12 ohms, which we got just by solving what they gave us. So 36 ohms is the correct answer. You have to remember that it's asking for the value of the resistors and not the total resistance of the circuit. The total resistance of this circuit is, okay, well, we have to combine these three parallels, and then we have, if we combine these three, then we have a series circuit of 10 ohms, whatever these are, and then R1, 5 ohms. So let's combine these. So 4 ohms, 6 ohms, and 4 ohms, 6 ohms, and 12 ohms. So 1 over 4 plus 1 over 6 plus 1 over 12. 1 over that gives us 2 ohms for all of these. So if you can ignore all these, you can redraw the circuit. 2 ohms. Just ignore all of that. Let's do this. So 2 ohms. Now, since we have a series circuit, so series, we have the battery, this is in series with that, this is in series with that. So we could simply just add up these values of resistances. So 10 ohms plus 2 ohms plus 5 ohms, 10 plus 2, 12 plus 5 equals 17. And that is our answer. If three resistors of 3 ohms, 5 ohms, and 22 ohms are connected in series in a 28 volt circuit, how much current will flow through the 3 ohm resistor? So this is kind of a trick question because we know that in a series circuit, the current will be the same for each resistor. So I drew a little diagram here. So we have our totals: total voltage, total current, total resistance, and total power. They give us total voltage, 28 volts. We can get total resistance by just simply adding all three resistors, gives us 30 ohms. And to get our current, we could simply do Ohm's law. 28 divided by 30 gives us 9.33. 0.933 amps. So since our current in a series circuit would be the same for each resistor, our answer would be 0.933 amps. C. When the landing gears are up and the throttles are retracted, the warning horn will not sound if an open occurs in wire. So we have 4, 2, and 9. So we have the warning horn. A warning horn needs power and ground. So it already has power consistently coming into it through wire 7. So it's saying the throttles are retracted, giving us a pathway. And the gears are up. So this is up. Ignore this. There's no, ignore this. And this is up. So to get power and ground, it will need to come in through 7, through 6, through the throttles, through 4, through the open, up landing gear, through 14, into ground. There's really no other way for it to get ground. So if we go through 5, so it's nothing there. If we go down here, we go down here through 3. Remember, this is up. Well, it gives you a down indicator, but since this is asking if it's up, there's no pathway to ground through this section. So the only wires we're dealing with are 7, 6, 4, and 14. So the only wire that could not make it go off would be number 4, wire number 4. What is the impedance of an AC circuit consisting of an inductor with a reactance of 10 ohms, a capacitor with a reactance of 4 ohms, and a resistor with a resistance of 8 ohms? So we have a capacitive reactance and an inductive reactance. So our inductive reactance is 10 ohms. So XL would be 10 ohms. So let's redraw this formula. And then our XC, capacitive reactance, is 4. And that's squared. Plus our resistance, 8 ohms. And that's squared. And then all of this is square root. So we could solve 10 minus 4, which gives us 6, and let's redraw our formula. So square root of 8 squared plus 6 squared. So 8 squared we know is 8 times 8, 64. So square root of 64 plus 6 squared is 6 times 6, 36. So we know 64 plus 36, 64 plus 36 is 100. And the square root of 100 equals, so 100 square root gives us 10. 10 ohms. That is our answer, C. With the landing gear retracted, the red indicator light will not come on if an open occurs in wire blank. So we have the red indicator light. It already has constant ground, so all we need to worry about is power. So if you follow the press to test circuit, remember, if it's a small triangle shaped at the end of the wire, it's a press to test circuit, so that's not gonna matter. That only comes on when you press it, when the pilot presses the light. So we could ignore all of pretty much anything coming from here on out. We could ignore all this. So to find power, it's definitely gonna need to come in through wire 8. Wire 8, let's trace it. Okay, and it's definitely going to need to come in through the up limit switch. So the only way it could come in through the up limit switch is from the bus through this circuit breaker, through wire 19, and if it's up through these contacts, back through wire 8, and closing the circuit. So wire 19 would be our answer. It will not come on if there's a break in wire 19. Find the total resistance of the circuit. Okay, to find the total resistance, we're going to have to combine some of these values. So we can start by combining these two parallels and make them in series with R2. So we know to combine two parallel resistances, you could use the formula 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. So we have 12 and 6, so our formula would be 1 over 12 plus 1 over 6. Then we can redraw the whole schematic and continue on. So 1 over 12 plus 1 over 6 gives you 4 ohms if you combine these two resistances. Let's redraw it. We have our 24-volt battery. We have this, and this is the one we just combined, which gave us 4 ohms. We have 12 ohms, another 4 ohms, and 18 ohms. So what we could do now is we can combine 4 ohms and 12 ohms simply by adding, because they're in series. So if we add them, 12 plus 4 gives us 16. We can redraw the circuit. There's our battery. We still have 18 ohms over here. We still have 4 ohms over here. And we just got 16 ohms from combining these two, which is this. So now, again, we have two parallels, 4 ohms and 16 ohms. We could do the same formula. So let's do it. So we had 4 and 16. 1 over 4 plus 1 over 16. And 1 over that is 3.2 ohms. So 3.2 ohms. Let's redraw it. So we're gonna have our battery, our 18 ohms, and our 3.2 ohms, 24 volt. This really doesn't matter, but I'm just adding it just for the sake of drawing it. So this is now a series circuit. Find the total resistance of the circuit. So the total resistance would be 18 plus 3.2. 0.2 gives us our total resistance, 21.2 ohms. And our answer is
C.